All right, so this is about the distributive property, and what we're talking about here is how can we take these expressions and rewrite them using the distributive property. So we've looked at it before where we have like 3 times 4 minus 2, and of course we could subtract 4 minus 2 and have that be just 2, and 3 times 2 is 6. What you can do is you can also take this term outside and say it's 3 multiplied by all of this. So we could have 3 times 4 minus 3 times 2. And 3 times 4 is 12. 3 times 2 is 6. And 12 minus 6 is 6. So that's what we got before. So that's what we're going to do. We're going to use the distributive property here. And what I did is I took these these terms here, this red term and this blue term, and I said, what are the prime factors of both? So I broke them down to its smallest part. So 2y squared was 2 times y, and 5y was 5 times y. Up here I have something to remember, right? X squared is x times x, so y squared is y times y. What I'm looking for is the common factor. What factor do each of these terms, the blue term and the red term, have in common? They both have a prime factor of y. So that means that y times 2y, so y times 2y is 2y squared, and y times 5 is 5y. That is an equivalent expression. This expression here is equivalent to this one here. And I should have done these in red. So this is the red term. This is 2y minus the 5 blue. All right, let's try the next one. So this one, we're taking a common factor and we're distributing across both terms. So we're taking 3 and we're saying, well, 3 times 8. So this would be like our red term. 3 times 8 minus 3 times 2z. And what do we get? And what do we get? Well, 3 times 8 is 24. Minus, what is 3 times 2z? Minus 3 times 2z is 6z's. Do that, Mark. So that is using the distributive property. So here, these two are equivalent. This expression is equivalent to this one here using the distributive property. So is this here in the middle. Those are also equivalent. All right, so 24 minus 6z is the same thing as 3 times the quantity 8 minus 2z. So what about here? So here we've got the red term again, the red term and the blue term. So here we go, red is here, so let's break that down. So that is 5 times z squared is z times z, can't go any further, minus 15, but 15 times z, 15 can be a product of some smaller numbers too. 15 is 5 times 3. So I'm going to rewrite 15 as 5 times 3 as a product of its prime factors. So the common factor, all right, so what is being multiplied by everything? So what's being multiplied by everything here? Well, the 5 is in the blue and the red. So 5 is a common factor as well as AZ. So 5Z. So this here is 5z times z minus, and this is 5z times 3. So it's this 5z that is common for both. So that's what goes outside, and what's left on the inside is a z minus 3. So do a quick check. If I took 5z and multiplied it by z, I get 5z squared. And if I took 5z and multiplied it by 3, I would get 15z's and a subtraction in the middle. So this expression here is equivalent to this one here. They are the same. All right, last one. So here we go. So red, let's do my red expression. So 4 times y, which is the same thing as 2 times 2 times y, plus the blue expression is 6z, and 6z is 6 times z, which is the same thing as 3 times 2 times z. So what is shared for both? Ooh, in this case, it's not too much. It's the 2. There's a common factor of 2. So when I rewrite like this. I rewrite it as 2 times what? Well, it was 2 times 2y. And, right, it was 2 times 2y. And it was 2 times this stuff. And 2 times 3z. So this expression is equivalent to this one here. So 4y plus 6z is equivalent to 2 times the quantity 2y plus 7z. All right, thanks.